All right, the last of the four methods that we're going to go over today is the quadratic formula. And many of you remember the quadratic formula because you sang a song that kind of went to the Pop Goes a Weasel. I'm not much of a singer, so I'm going to do the quadratic formula story. Okay, so the quadratic formula is one of the four methods that will help you solve a quadratic function. And a quadratic function is always in the form ax squared plus bx plus c. So it has to be a power of 2. Okay, so if you take a look in the highlight that this is the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And sometimes it's hard to remember, so we have memory devices that help us remember things, right? So this is how what I learned when my niece was in 8th grade and she was learning about quadratic formulas, right? There once was a negative boy. See the negative b? So there once was a negative boy who couldn't make up his mind whether he wanted to attend and then you see the radical sign, so the radical party. The boy was so squared, because you see it's b squared, that he missed out on 4 amazing, or you can say awesome, either one. I'll say amazing or awesome. And we'll put chickens. Right? It used to be chicks. We're going to say chickens. And the entire party was over by 2 a.m. Okay, so here we go. There once was a negative boy who couldn't make up his mind whether he wanted to attend the radical party. The boy was so square that he missed out on the 4 amazing chickens, and the entire party was over by 2 a.m. All right, now what the quadratic formula could do is it can help us with a couple things. One is that part of the quadratic formula, which is called the discriminant, that is the inside of the quadratic formula. The discriminant is b squared minus 4a. If you take a look at it, it's not the entire thing, it's just this inside value. That inside value can help you determine what type of number are you going to be getting. And what is the nature of the roots? Okay, it doesn't tell you the answer, it just tells you what type of answer you're going to get. Are you going to get 2 solutions? Are you going to get 1 solution? Or are you going to get no solutions? Okay, so if b squared minus 4ac is greater than 0, so if it's greater than 0, then we get 2 solutions. If b squared minus 4ac equals 0, then we get we get 1 solution. And if b squared minus 4ac is less than 0, we get no solution. So let's take a look at this problem right here. This 4x squared minus 5 equals 6x. And you see the steps are highlighted in green. There are several things we want to do. One is to find the discriminant. 2 is to determine how many solutions and the nature of the roots. And 3 is solve using the quadratic formula. So in quadratic formula, it's really important that your equation equals 0 and that's in descending order. Descending means it goes down in power, so like x cubed, x squared, x, no x. Well, my equation doesn't equal 0, so I have to move this 6x over. And when I move it over, it becomes negative 6x. So 4x squared minus 6x minus 5 equals 0. Right? So I want to make sure next that I know what A, B, and C equal. So A equals 4, B equals -6, and C equals -5. So A is always a number in front of x squared, B is always a number in front of x, and C is always the constant. So let's go ahead and figure out what the discriminant is. Okay, so discriminant. So I want you to pause and I want you to take a second and figure out what would b squared minus 4ac equal. Would it be greater than 0, equal to 0, less than 0? Well, -6 squared minus 4 times -5, make sure you're watching your signs, 36 plus 4 times 4 is 16, and 16 times 5 is 80. 36 plus 80 is 116. Because that is bigger than 0, we know that we're going to get what we call two solutions, two real solutions, because we're going to learn that sometimes you can get imaginary solutions. So two real solutions. So our discriminant is 116. And the nature of our solutions is that they're two real solutions. Okay. The last thing I want to do is I want to figure out is what does x actually equal, right? So I'm going to use the quadratic formula to help me figure out what x equals. So x equals -b plus or minus the square root of the discriminant all over 2 times a. So x equals -b. B is -6 plus or minus the square root of the discriminant all over 2 times a. A is 4. So negative and negative make a positive. So x equals +6 plus or minus the square root of 116 all over 8. Now the square root of 116, can that break down? Well, the square root of 116 is 2 times 58. 58 is 2 times 29. So what do I have a pair of that can come out of the square root? I can factor out a 2 and I'm left with a 29. So I need to rewrite my solution as x equals 6 plus or minus, instead of the square root of 116, I need to write 2 square root of 29, and then I put that all over 8. Now, these are two solutions. One solution is 6 plus 2 square root of 9 all over 28. I'm sorry, all over 8. And the other one is 6 minus 2 square root of 29 all over 8. And those are called real numbers because they're not imaginary. You're not taking a square root of a negative. You can really, if you were to put this in a decimal form, you could approximate where those numbers exist. All right, let's take a look at this next problem right here. So 3x squared plus 2x plus 5 equals 0. First thing I do is that my equation has to equal 0. A equals 3. All right, let's take a look at this last problem. 3x squared plus 2x plus 5 equals 0. The equation already equals 0, so that's good news. So the first thing I want to do is I want to figure out what A equals, what B equals, and what C equals. So once I figure out that A is a number in front of x squared, which is 3, B is a number in front of x, which is 2, and C is a number by itself, the constant, which is 5, I can proceed to find the discriminant. So, oops. Now remember, the discriminant, its job is to determine what type of solutions are you going to get. Okay, will you be getting 2 solutions, 1 solution, no solutions? So the formula is b squared minus 4ac. So if I do parentheses squared minus 4 parentheses times parentheses, I stick b, which is 2, a, which is 3, and c, which is 5. I get 2 squared, which is 4, and negative 4 times 3 times 5 is negative 60. So 4 minus 60 is negative 56. Because negative 56 is less than 0, I know that I'm going to get what we call no solutions. And let me clarify that. You're going to get no real solutions. The reason why you're not going to get any real solutions is because you get what's called 2 imaginary solutions. So now I'm going to use the quadratic formula, which says x equals negative b plus or minus the square root of the discriminant all over 2 times a. So x equals negative b, b is 2, plus or minus the square root of the discriminant, which is negative 56, all over 2 times a is 3. When I clean this up, I get negative 2 plus or minus the square root of negative 56 all over 6. The square root of negative 56, and we discussed this the other day, is anytime you have a square root with a negative, automatically your answer is going to have an imaginary solution. 56 breaks down to 2 times 28. 28 breaks down to 2 times 14. And 14 breaks down to 2 times 7. So I can factor out a 2. I mean, not factor out, but take out a 2 in addition to I. And what I'm left with is 2 times 7, or 14. So it's 2i squared of 14. So I can rewrite this as negative 2 plus or minus 2i squared of 14 all over 6. Now, if you take a look at all the outside numbers, this negative 2, this 2i, and this 6, notice that they're all divisible by 2. Divisible meaning what can all of those terms divide by? They all divide by 2, so I'm going to get negative 1 plus or minus 1i squared of 14 divided by 6. You do not divide the 14 by 2 because the 14 is inside the square root, where the negative 2, the 2i, and the 6 are outside the square root. Now, these are not going to be real solutions. These are what we call imaginary solutions because it has the letter I, and it's a completely different number system. We'll be discussing this a little bit more the next time I see you. Have a great day.